In this video, I'd like to give one more example demonstrating some ideas of scope and how this interacts with functions. So I've defined a very silly function called the try-changing function that takes in two parameters, I and m. Our function is going to try to change the values that have been passed in for the variables I and m by incrementing the I value by 5 and adding the list element b to whatever is in m. So it's a very small and silly function, but this is the example that we'll work with for simplicity's sake. What I've done with this function, in order to mimic how things work in real life, where maybe we have one coder who's defining a more complicated function somewhere and saving that code in one document, and then we go to our main function where somebody else might be coding and simply wants to access that function to use for their purposes. I've taken my function, try-changing, and I've placed it in a separate file where the algorithm and the procedure that's presented in the function is entirely hidden from the person who's using the function. In this sense, it might be the case that the programmer who's working in our main.py file has no idea of the parameter names that the try-changing function is using, and so the user might already have values with those exact same variable names inside of their code. What I'd like to do here is print the current contents of the variables I and m, then run our try-changing function, and afterward take a look at the contents of the variables I and m to see what's going to happen here. So pause the video for a moment and make a prediction about what you think will be printed to the screen, and after you've made your prediction, unpause and we'll run the program and see whether or not it's what you expected. When I run the code, we feel really confident about what's going to be printed to the screen before we call the function. We've just defined these variables and we know what's in them. We can see it on lines 3 and 4, and indeed that's what's printed here. Now our try-changing function was meant to add 5 to the value of I and add the element b to the list m, but as you can see from what's printed here, only one of those changes had any effect. The contents of the variable I has remained the same, while the contents of the variable m has in fact changed. Now the reason for this, as I've tried to hint at by the naming of my variables, is that the data type of the variable I, which in this case is an integer, is an immutable object in Python, while the data type of the variable m, which is a list, is a mutable data type inside of Python. Mutable data types are those that are meant to be able to be changed in their current location in memory. Immutable data types in Python, whenever we wish to quote-unquote change their contents, what truly happens is that a new location in memory is created with the new value, and then we reassign the name to that new location in memory. And all of that that's going on in the background is having an effect on whether or not these changes made by the function are permanent. In order to demonstrate this a little bit more clearly, I'd like to change what's being printed to the screen. And instead of printing the contents of the variables I and m, I would like to print their actual locations in memory at 3 different points in this program. To do that, I'm going to use the Python function id. So what I've now changed in line 6 is that instead of printing the actual contents of the variables I and m, I'm going to have the computer print their physical locations in memory. And I'm going to do that before our function call and after our function call, and also during our function call, so we can see what's happening in the background of our program. Now let's run our code and take a look at what's happening. It may be difficult to see because these memory locations are very long strings of digits, but if you focus on the variable I and the last 3 digits of what's being printed to the screen, you'll notice that the before and after strings of numbers end in this 008, while the during string of numbers ends with a 168. What this is showing us is that internally on the computer, we're talking about the global variable I, both before and after the function call, but during our function call, we are referencing the local occurrence of the variable I, and these have different locations in memory. So the change that we made to the variable I was to the local variable I. It is that local variable of I that ultimately did hold a value of I plus 5, in this example 8. That change was not made to our global variable I. So the 2 times we refer to the variable I within the main program, we're referring to that global variable and not the local variable. You can see that with these different last 3 digits for the global variable, local variable, and then again referring to that global variable. However, my object M has the precise same location in memory in all places, both before, during, and after the function call. This is because my variable M is mutable. We are able to change its values in place in memory. When we make changes, it's all occurring at that same location and memory. So Python is not duplicating the mutable object when we pass it to a function. And as such, we are making the changes to the exact global variable that we passed in and not creating a local copy. So this is something that you need to be aware of when you're passing immutable objects to functions in Python. Any changes that you make to the contents of those variables inside the function will not be permanent. On the other hand, if you're passing mutable objects to functions in Python, the changes that you make may be permanent. And none of these things is necessarily good or bad. It's not that we want one behavior over the other universally. We want one behavior or the other based on context, and being aware of when these changes are permanent and when they're not will be useful for us when we're debugging our code.